right, it is now recording. So, and I'll do WebEx as well.
This meeting is being recorded.
So any of you can rewatch this. Okay, so let us start by talking about what Python is. Okay, so Python is a programming language, and it's a way that you can send commands to a computer to do work for you. And the reason why we are doing Python over other programming languages has to do with both the popularity of the language and, more importantly, in our specific scenario, is because there's a lot of libraries that help us out that are made for Python. And I guess let me go ahead and explain what a library is. So when you're writing Python code or any code in any programming language, you're basically trying to tell the computer to execute certain commands. And if you're trying to do something like a calculator, for example, you tell it that when you have two numbers and you press the plus symbol, it's supposed to add them together, right? So you have a command to store the information that you're going to add together, and you have another command to actually tell it to do the addition, and then another command to actually read the information for each of the two numbers you're adding together, and another command to tell you to print out what the resulting of the addition is. So the first thing that you'll notice about that is that we have to break up what would otherwise be like, well, just add two numbers together into more defined instructions. So that is kind of what like the programmer's mindset is all about. So, if I tell you, okay, can you please guide me on how to cook an egg, for breakfast? Like I want to cook a scrambled egg. You might initially say something like, well, I'm going to go ahead and say to you like, okay, well, get some eggs out of the fridge or storage if you don't refrigerate your eggs, and then crack them open and then mix them up, throw them in the pan and then cook it, and then you're good to go, right? And that is enough for somebody else to probably replicate what you're doing. So replicate you making the eggs. However, if you're telling these instructions to someone that has never cooked before, or like a little kid who just has no experience in general with anything of that nature, it's not going to be enough, because you are skipping a lot of things that might be obvious to you, but not to someone that has never done something before. And so you have to break things down kind of like into like atomic steps, very, very tiny steps that are very clear on what you're supposed to do. And you can go really, really, really crazy with something like this. So for example, the simple act of taking eggs out of the refrigerator, that can be broken down into a lot of steps. For example, you gotta tell somebody where the refrigerator is. You gotta tell somebody how to open a refrigerator door, first of all. You got the handle, pull the handle with a certain amount of pressure, and then swing open the door. And then you have to tell them where in the refrigerator the eggs are located. You're assuming that they're gonna search around for the eggs, or that their eggs, they know where their eggs are. Computer doesn't know that kind of stuff. You gotta tell it where it is. So you gotta be like, okay, second aisle. If you look at the refrigerator into aisles, go two up and two right or something like that, and then look for a container that is made out of styrofoam or carton, whatever containers you get, and then locate that, grab that with both of your hands, remove that from the refrigerator, find a location to place it on, so such as a table or a tabletop counter, put the carton there, open the carton, identify two eggs. Eggs look like this. They're egg-shaped or oval shaped. They're white. Make sure that you're looking for two of them, not just one. Remove them from that, and then close the container, the whole instruction to put it back, and so on. And even then, that might seem very cumbersome, but when you're trying to tell a computer to do something, that's probably not even enough. You got to go even more detailed, like, okay, what kind of hand movements do you need to be able to grab an egg and remove it? So move your hand this many millimeters, close your fingers this much so that it can actually grip into the egg. That's how meticulous you have to be when you're thinking about programming, okay? Now, hopefully you're thinking what I'm thinking. That's a pain to do. I don't want to have to do if I'm trying to make a program for like a robot to actually grab something, I don't want to have to code every single time how many millimeters each finger has to move so that it can do the right hand shape to be able to grab an egg and then lift it and then, you know, make sure it doesn't go too tight because it'll crush the egg, or go too loose that the egg falls. I don't want to have to do all of this, right? It's just too much work. And you're very right. It is a lot of work. However, someone has to do it. But here's the beauty of it. Somebody probably already has done it. That's where libraries come into play. So libraries are basically pieces of code, classes, functions, other things, but think of them as pieces of code that somebody else has done for you, or not necessarily for you, but they've done for the world, maybe for money, maybe for free. And now you can use those to skip some of those cumbersome steps. So there might be a library for things like a robot that can already have a function or a piece of code that can grab an egg for you. And so now you don't have to give it those extreme specifics. There might already be a function to take something out of the refrigerator. And so all you got to do now is you got to tell it what item you want to take out, and then the library will take care of the rest. You'll be like, okay, there's a library command for opening a refrigerator door. There's a library command for extracting something, for finding something, and then maybe for extracting something from the refrigerator. And you don't have to worry about grabbing, the movement of the hands, or things like where the refrigerator is, etc., etc. Okay? Or even there might be just an entire library that literally all you have to do is say cook an egg and it'll cook it for you. I mean, that's the ideal, right? Because it's literally one command that you have to send it, and it'll take care of everything. And that's really what we want to do. That's kind of like the end goal. And so that's what libraries are. They allow you to not have to do the stuff that is kind of boring and cumbersome, and allow you to actually apply your knowledge to get stuff done that matters. How does this apply to data analytics? Well, for example, if you're trying to do something mathematical, like find the average of a bunch of numbers, you don't want to have to actually code, like add all numbers together and then divide them by the number of numbers, and bam, you got your average, or other like statistical analysis, or any mathematical operation that you might think of. You don't want to have to do by hand or in a computer, like literally write every single instruction. There are libraries, math libraries, that allow you to do all of this. You simply call a line of code that's something like, average, and then you feed it whatever the list of number is that you're trying to do, and then bam, it'll give you the average back. That's what you want to do. And of course, if you're doing something fancy with machine learning and whatnot, it's the same thing. You just feed it your data, you tell it what algorithm or operation you want to do. It does it for you. It might take a while, but it does it for you, and then you get it back. And so you can hopefully start to appreciate how important libraries are for programmers. And ultimately, you want to use as many libraries as possible, because it's less work that you're doing yourself, like raw, like by hand, And so Python, turns out, that is a very popular language, and because of that, a lot of people that make these kind of libraries have made it for Python. And then Python has gained this sort of notoriety along with R, another programming language, to be used for things like data analytics and machine learning and some interdisciplinary or multidisciplinary like doctrines coming in and trying to code, because it's a very I wouldn't say easy, but it doesn't have a huge learning curve, whereas other programming languages might. And so because of this, all these people have said, well, this is a great language to do libraries on. And so it's kind of like a circle of life, or catch-22, where like you have more people coming in because it's easy, and then you have more developers making stuff for Python because there's a lot of people using it, and people want you to use what they make, especially if they're selling it for money. But even if it's for free, they would like you to use it. So does anyone have any questions so far? I'm just going to go behind me for a second and grab a bottle of water. So I'll be back. There we go. So cheers, everyone. Okay. You can also write questions in the chat if you don't want to talk. Although I don't think that your voice will be recorded on the video from YouTube. The WebEx it would. So yes. Okay. Thank you. So that's what libraries are, and that's why we use Python, because it's a popular language, and also, don't underestimate that. The fact that it's popular is a good thing for you, because there's a lot of tutorials, there's a lot of support, there's a lot of people that know the language, and a lot of people that want to help you out. And so that makes it easy. If you pick like some really obscure language or a relatively new language, then there won't be that much support, which means that you're kind of stuck. Whereas like, I guarantee you that at least for anything you do in like a school level or like a basic level, unless you're doing something like really, really hardcore and advanced, I guarantee you that if you run into a problem, it's a problem that has been, somebody else has run into it. In fact, not just one person, but probably 100, and they have asked about it online, and somebody has helped them and have found an answer. That's how many people use the language, and that's how much information there is. There's a website that a lot of programmers use and know and joke about, and that is called Stack Overflow. And whenever you Google something like an error that you're getting when you're trying to run a piece of code, you probably run into this website as something that shows up in the Google search results. It's a website where people ask questions and other people can answer the questions, and they rate them up or down based on if it's a good answer or not, and that's how you pick the best answer. It's not always right, but at the majority of the time, it's either right or it gives you enough information to kind of proceed and figure out your solution on your own. So yeah, welcome. If you Google something and you get that link, welcome reading it. And and the joke side is that a lot of the times people ask the same question over and over again, so people respond like this has been asked before, and then they don't answer it. But then you can't find the one place where they did ask it, which is why there's a lot of jokes about the website. But it's still a great website, great resource, especially for finding things that other people have asked, which more than likely, again, if you run into an error, I guarantee you that somebody has run into the same error, and there's somebody that already solved it. You just have to find that information. So it becomes a little bit of a an egg hunt, basically. We got the egg theme going on today. Okay, so Python. There's two versions of Python. There's Python 2 and Python 3. 3 is sort of like the evolution of Python. I can probably pull up from Wikipedia like the dates of when like Python 3 came out. If you just go to the Wikipedia, you can find probably all like the history of Python and whatnot. Yeah, I'll post it on the chat, but I'm sure you can all Google that on your own. And as you can see, the latest release was actually 1 day ago from recording. So this was recorded on August 31st, 2021, and August 30th, 2021 was the latest release, which was 3.9.7. And what it means is that when you see something like, okay, 3.9.7, that's the version number. And it's a numerical thing that increases. So probably the next version will be 3.9.8, and then and so on, right? And it depends on the developer, but like they typically keep this number like they won't change the 3 here. They'll change the one before it when it's like a major revision, and then they'll change this when it's a minor revision. Okay, so you might see like 3.20.50 or something. Okay, depends on who you ask. So don't expect like, oh, we're almost at 4, they're just gonna flat out go to 4. No, they probably, well, I don't think they will, but who knows, but probably won't. Okay, and so Python 2 was discontinued in 2020, which means that it's no longer supported. And the reason why there's a difference between 2 and 3 is because when Python came out and they were adding all these great features to it, they don't want people to write a bunch of code, such as the libraries that I'm talking about, and then they go away and update the language and they change some of the syntax, and then bam, the thing doesn't work anymore. Because then you have to go back and fix all of that code. And so this is not something that is strictly related to just Python. If you look at programming languages in general, we're still running code in like the world that was written in like the 70s, or probably even 60s. And the only reason we're running that code is because updating that code to a modern programming language and updating the architecture to support that is horrifying. Like it's a horrible headache. So it's better to take the approach of like, if it's not broken, don't fix it kind of thing, or like don't touch that code. Unfortunately, right now, as you have all seen in the news with all the cybersecurity issues and the ransomware and the hacking and whatnot, people take advantage of this because it turns out that usually you find exploits in old code because it's really hard to make something perfect. There's always going to be some sort of security issue or just something that makes it not perfect. The longer the time passes, the more likely it is to find such issues. And so A lot of the times companies are running old code and there's exploits that were discovered for this code. They don't update because either they're not aware that there's exploits, they don't care, it costs too much to upgrade, and so they just let it be. Again, if it ain't broken, don't fix it kind of thing. But then hackers come in and take advantage of that, apply some ransomware, and now your company is screwed, right? But that's a little bit going off topic. What I'm trying to get to is that people don't like to have to update their code. If I write a program that works really nicely, I'm working with Dr. Cummings, and I've created this program that basically is able to check in clinicaltrials.gov, find all the clinical trials that are for Alzheimer's that have certain requirements and generate those. And I can generate those on the fly. So it's like I can, anytime that I want to get an update, I hit a button and 1 second later I got the latest stuff ready to go. That's cool. But like, if every 5 minutes, whenever Python updated or somebody else updated, they broke my code because they changed something about it, then it would no longer be cool, because what's the point of automating it if I have to fix it every 5 minutes, right? And so that's the mentality that is why we don't like when code changes. And so because of that, whenever you're writing a programming language and updating it, if you want to add features, that's okay, but you don't want to break existing features. And to better understand that, I need to explain to you what syntax and semantic are. So let's talk about that. So this is if you're a programmer, if you're like taking a computer science bachelor's degree, syntax and semantics is like one of the first things that we teach in those classes, CS 135, and they're very important keywords that you're all here because you want to do data analytics, and it's okay, you don't care about like the computer sciencey side of it. But still, some fundamentals like these two words are important to know. So I'm not going to really be like, the vocabulary list and whatnot. But this is one where I'll make an exception to actually like define these very important words. Also, when you're getting help with your code online, if you ever get stuck, you might run into these and you might not know what they are, or you might confuse them. So anyways, syntax turns out to be the rules of a language. Can also be defined as the grammar of a language. On the other hand, semantics is the logic or meaning of your code. Or in the specific piece of a language of what will be a generic term for this instead of your code. The logic or meaning of your program. Yeah. So let's understand this with English, because we all here know English, I hope, right? Otherwise I'm speaking and you're not understanding me, that would be bad. So if I write a sentence like, I eat food. And I'm not an English person, like an English major. In fact, English is my second language. So I might need your help on this, since you're all here. Let's understand what each of these words is classified under the English language. The one that I know for sure is this one. Eat is a verb, right? Now, you tell me, what is food? Is food a noun? I believe that's what it's called, right? Noun. And then I is a pronoun, right? Please correct me if I'm wrong, or tell me if I'm right, because I don't know. This is a data analytics class, not an English class. So I believe this is how that one goes, right? And I can actually make this fancier by adding other types of words. So I think if I put the word tasty here, this is now an adjective. And I can also add something like an adverb, right? If I say, I quickly. Right? Come on, someone help me out. You're making the non-native English speaker like tell you English. Someone just confirm that this is right? I mean, for the sake of the example, it doesn't have to be right, but I think it is. Okay, there we go. We got somebody. Great. Okay. So we have different kinds of words in the English language, right? We have these pronouns, adverbs, verbs, adjectives, and nouns. And adverbs are supposed to, I believe, describe what a verb is. And an adjective is supposed to describe what a noun is. And a pronoun is like some weird thing that I can't really explain to you. It's just a thing. I guess it's a version of a noun that does something else. Okay? So, when we're analyzing what the syntax of this language is, it might be rules like, okay, you are required, if you have an adjective in your sentence, to follow it or to have also a noun for it. So like the syntax of this might be like, if an adverb is present, then it must be followed by a verb. This might be like a grammatical rule, okay? I don't know if it is actually, but it seems like it. I think another grammatical rule is that all sentences have to contain a verb, right? So all sentences must contain a verb. I think. And probably a noun. Although I don't know, because if you say eat, period, I don't know if grammatically that is an English sentence. But you get the idea, right? You have these grammatical rules that that control how the English language is written and spoken, right? Okay. You have the same thing for programming. In programming, you have these rules of how you're supposed to put these special keywords, how you're supposed to put commands, and so on. And that's really what learning programming is all about. It's about learning these rules so that you can write things that are valid syntactically. When you have a programming language that can be compiled, you write that keyword, it means that it's fed to a compiler, and that compiler is going to take your programming code and convert it into binary code, okay? So let me show you the process of that. So you start out with code, and this code, it looks like English. If you've seen Python code before, and if you haven't, that's okay, but if you've seen at least some programming language code, it's English for the most part. I mean, some of the stuff might be weird, but it's basically a mixture of English and algebra. If that would be like a good representation of a programming language. And now I can show you examples if you want, but you get to see them as we start coding, right? So that's basically what it's like to write code, is just to write English with special grammar rules. Why English? Well, that's a much harder question to answer, because probably the people that develop some of the programming languages today knew English, and then there's the whole like English as being the international language, etc. So I think that kind of just established English as being the language that is used. You don't really see code based on other languages. And so the idea is to make the code as easily readable to human as possible. Ultimately, this code gets fed to a compiler, or in the case of Python, actually, it gets fed to an interpreter. But it still goes through some sort of translation. That translation is going to take the code and is going to convert it into one of two things. If it's something like C++, then you get binary out of it. Binary is a number system that is base 2, which means that there's only two symbols, which happen to be 0 or 1. So if you've seen any movie with coding or with Hollywood hacking, you see a bunch of zeros and ones on the screen. That's because it's binary, and they're probably like trying to be like, ooh, binary. So that's where all that comes from, okay? So the job of the compiler is to take something that is easily readable. So like, let me give you an example of code that could be easily readable. If computer.on start coding. So this is actually Python code, what I wrote right here. And as you can see, this is relatively readable. If computer on, start coding, right? Let's just say that that's some video game you're writing, and like if the computer's on, you can start coding or start Googling or something, okay? It's code because you're actually calling a procedure here, or a function with a little parentheses. Actually, They don't look like parentheses. Let me make sure I split them up. Okay? And here, this dot, we'll talk about what that does, member access. But you can understand that this is saying that if the computer is on, right? So while this is programming code, and it's meant for a computer to do things, it's also very readable for a human. Now, I could literally write the same code like this. Both are the same. Both do the same thing, or can do the same thing. However, I would argue that the second example is not as readable as the first one. So that's going to be another thing that we'll talk about, code readability, right? You want to make things that are easy to read. But the point is that if you take advantage of things like this, then you can make your code very easy to understand and read and follow, right? Naming your variables and things like that. We'll talk about all of that. But the point I'm trying to make is that when done right, code should be readable, even to a person that doesn't really know how to code. But even if they do, at least someone that knows how to code but like is not as experienced, it should still be very readable. A good programmer will do that. Bad programmer may not, but a good programmer will do that. Okay? So don't get freaked out when you see in Hollywood of just going up the screen and you're like, ooh, hacking, and all they're doing is just printing random stuff, garbage. I've seen that lots of times. Okay? So the compiler's job is going to take this nicely readable code and is going to make it into like pretty much impossible to read binary code. Like this. Okay? That's most programming languages. Although Python is a little bit different. Python doesn't really have a compile stage. What Python has is like an interpreter stage. So what happens with Python code is you have Python files, and Python files are terminated with a .py. So you can name whatever you want your file. Actually, I wouldn't name it. I would not name it Python, but like call it like my program .py. And what happens is this is fed into the Python interpreter. And the Python interpreter is going to convert this into Python bytecode, it's called. And it's kind of like this intermediary step for Python. And those are, I believe they're called PYC files. I don't quite remember, but it doesn't really matter, that's irrelevant. And then that is actually read by your machine, which internally still, everything at the end of the day is still going to be zeros and ones, but it just happens behind the scenes. And the reason why there is this intermediary step of this bytecode is because it allows your code to run in different machines. Because programs like C++, when you compile them for a specific machine, they'll work in that architecture and that sort of machine type, but they may not work in other machines that might be similar. So this is like the whole situation like when you have a program that runs on a Mac but not on Windows. That's because it's a program that was compiled for that specific system and that specific architecture. So of course, when you try to run it in a different architecture, it won't work. But the beauty of Python is because of this bytecode that the step from here to here can be done because it's the same regardless of the architecture. And then the step from here to here is set up whenever you actually install Python itself. So then you're guaranteeing that any Python code will run on your machine for the most part. Actually, I wouldn't say any, but I'd say like a large majority of it. So that's another reason that makes Python beloved. And also Java was the first language that really kind of got this involved with the Java virtual machine because it allows code to be portable. And that means that it can be run in different architectures and different machines without having to recompile it and potentially run into problems when trying to recompile. So another plus for Python, okay? So that's how you kind of work with Python. Now going back to syntax and semantics. So we have these rules, right? We have these rules that I wrote here for English, and then we have similar rules for Python, such as like this little colon right here after the word if, but there being something in between that, which is this stuff. Okay, that's a grammar rule in Python. Another grammar rule that's actually here, but you may not be aware of, is that I did put some space here. You have to tab things in Python to indicate scope. We'll explain all these terms later. Well, that's another rule. Those are grammatical rules. We don't have spacing rules in English. Nothing in English says that you have to like put special amount of spaces in special places. The only one where I would say that that's kind of a rule like that is like when you're writing papers and they tell you you're supposed to indent the first line of a new paragraph. But I don't think that's technically an English rule. That's more of like It's just a thing you do for pleasure of the eye to be able to read things better. But it's not something that is like official, I think. So there isn't really any spacing rules. As long as you space words with at least one space, you can put 2 spaces there, and you're not breaking the law per se. Okay. Things that are rules though in the English language is like you have to have a dot at the end of a sentence. So that's important. I would say another rule is you're supposed to capitalize things at the beginning of a sentence, right? And then of course I already said like things like verb must be there, adjective must come before a noun, or adverb must come before a verb, or maybe actually I don't think that's that one. That's because you can, I guess you can have an adverb after the verb too. So yeah, okay. So hopefully you all understand what I mean when I say syntax of something. That's going to be your rules or your grammar. Let's talk about semantics now. What is semantics? Semantics in this case, and they might have other meanings in other places, is going to be the logic behind what you're writing, okay? So whereas syntax is something that like an interpreter or compiler can check to make sure that it's correct. So like if you're feeding some code and that code is wrong, you will get compilation errors here. So if your code is wrong, if it violates any of the rules, then you get an error. And think about that the same way with like Microsoft Word. If you forget to put a period, or if you don't capitalize the first letter of each sentence, you will get an error. Like spell check will tell you like, yo, that's wrong. Or simply, if you mistype a word, that's actually the easiest one that I didn't mention you. The easiest example of a syntax error is that there is a given amount of words in the English language, right? And if you spell one wrong, that's a violation of the grammar. So like if you spell the word eat with 2 E's on it, technically that's a violation of that, and you'd get an error. It's the same thing with programming. If you spell reserved keywords wrong, if you don't follow these rules like putting the colons and the spaces and whatnot, you will get an error. And that's great because you want to get those errors, because that means your code is wrong and you can get them when you run the program, which allows you to fix it immediately. Those errors, not a problem to fix. Also, very easy to Google if you don't know how to fix. Semantic errors, on the other hand, those are a little bit trickier to resolve. And here's why. When it comes to semantic errors, that's logical errors. So if any of you ever taken a philosophy class, back in the day, in bachelor's degree or whatever, they taught you all these logical things like and or not, and they also taught you like all the fancy logic, right? To be able to express yourself correctly and to not make mistakes and to be able to argue correctly and those kinds of things, right? Philosophy, logic, all of that stuff. Some of that actually will apply in this class, especially the basics like Boolean logic, such as and or a not, and creating a logical statement. All that stuff will be useful. We'll go over it when the time comes for it. But what I'm trying to say is that when you have a semantic error, that means that what you're trying to do is not the same thing as what you wrote. You can also have, I suppose, semantic errors in the English language. So for example, let's take the first sentence. I eat food. Okay? And let's say that you were adding that adverb to it. So that quickly adverb. And this might seem a little too obvious, but it's an example. And hopefully, I wish errors like this were as obvious as in code, but they're not. But then again, we have years upon years of experience of writing English, whereas some of you might not have any experience with writing code. So you can expect how you pick these things up as you code more and more. So let's say that this is what you were trying to say. I quickly eat food. This is grammatically correct. So your code compiles, or your English compiles, gets interpreted correctly. No problem there. But guess what? Suppose that what you were trying to say, what you were trying to convey to someone is that you eat food at a very slow rate. Is that what you wrote? No, you wrote the complete opposite. You were saying that you're trying to eat quickly, when actually you're like eating slowly, right? So maybe you meant to say, I slowly eat food. Or let's make a more realistic example. Because how do you go from quickly to slow? Unless like you were just like half asleep when you wrote this, right? But what could be more viable is instead of writing quickly, you wrote quietly. And those are very similar. In fact, there's only 2 characters that are different between them. We have from quick and quietly, right? Quickly. I actually did not plan this, but I kind of like the fact that quickly and quietly are so close. Because actually, little line there, that looks like a K now. And if you screw up your E's by not closing this enough, it looks like a C. So like someone might actually interpret that your quietly and your quickly are almost the same, right? So that's very, very, like if you're scanning this like OCR, this might get read as quickly instead of quietly, right? Oh, this is a beautiful example. I'm sorry. This is like one of those things where you accidentally do something really cool. I like this because they're so close. So, technically speaking, both of these sentences are grammatically correct. They are. They both pass your spell checker. Microsoft Word won't complain about either one. However, they have completely different meanings, right? One of them is talking about the speed of your eating habits, and the other one is talking about your etiquette, as that you quietly eat versus like blobbing everything together and making a bunch of noise and disrespecting people, right? Totally different meanings, but are grammatically correct. It's practically, well, never say never, but it is very, 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 very hard for a computer to know that you meant to say one over the other. It can't. And this is the same dilemma that we have with programming. When you write something, but you mean something else because you make a typo or because you didn't logically deduct the right, logic statement, the computer can't do much to help you there. These are the famous bugs that you hear about whenever like something doesn't work right. They're things that the compiler cannot catch because it's technically valid code, but you're not doing what you intended to do because of an accident or because you just didn't know any better. They're very hard to find and very hard to fix. The easiest way to try to fix them is to sit down and follow the logic of your code using a debugger, which at some point we'll get to show you. And then at some point you will see like, okay, you're describing your activities, and at some point you're like, wait a second, why are you making so much noise eating? Oh, it detected quietly instead of quickly. And then you're like, oh, let me fix that. That's kind of how it goes with code the same way. You're looking at some code, you're expecting like 2 plus 2 to equal to 4, but then you see that it's equal to 5. And you're like, what? And then you go look and you see that you made a typo. Instead of saying 2 plus 2, you said 2 plus 3. And then you're like, oh, that's the error. And you fix that, right? Because when you think about math, 2 plus 2 is equal to 4. But if you accidentally write, and when you're keying things in on the keyboard, the 2 and the 3 are next to each other. So you may accidentally type a 3 there instead of that. And then now things are not going to be equal to 4. They're going to be equal to 5. So it can be something as simple as this, or something really complicated with your logic that's just wrong, because it's just logic can be hard sometimes, okay? So this is not to discourage you like, oh no, I have to be super meticulous. But I'm just saying that it's good to understand these kind of errors, right? When something works, but it's not doing what's expected, it's because the meaning is wrong or you have a semantic error. When something just does not even run because you're getting something like an exception or it just does not interpret and whatnot, that's a syntax error. And again, I would rather have any day of the week a syntax error over a semantic error, because those I can detect and fix. Semantics are like those hidden things that are going to make the bridge collapse if you're not careful, kind of thing. So that's my spiel about syntax and semantics and why they're important to understand, so that you can know which kind of error you have and how to approach fixing that error once we get there. Okay? Going back to Python 2 and 3. Python 2 and 3 have different syntax rules. They are very similar, but they are different. And that's the whole reason why they swapped over, because you can keep adding additional syntax rules. You can keep adding features and code and language as long as you don't modify existing syntax. But there comes a limit when you're like, okay, this thing is getting really complicated and I can simplify it a lot if I can simplify some of the rules. If you do that, code breaks, because now code that was syntactically correct in the past is no longer syntactically correct. And that's when you're like, oh, snap, I gotta go fix code. That's what happened between Pythons 2 and 3 and why they made that swap. They were like, we've had enough with 2, we have to add new features in, so we're gonna make that break. And even though Python 2 was discontinued in 2020, let me tell you when Python 3 first came out. Let's go look into Wikipedia. Python 3 was released on December 3rd of 2008. So December, what is this? Did I say 3rd or 8th? 3rd. How long ago was that? Well, for recording, it was almost 13 years ago, right? That's a long time. And only in 2020 did Python 2 support end. It turns out that initially 2.7, which was the last version of 2, had an end of life in 2015, but was postponed until 2020, and this is from Wikipedia, out of concern that a large body of existing code could not easily forward ported to Python 3. And ultimately, that's always the big dilemma. You want to update, but people don't update, so you keep pushing the deadline, hoping that people see the deadline close and update it, and eventually you're just like, we just gotta cut our losses kind of thing. It took that long to get rid of this. And even today, Python 2 is still out there and is used a lot, and people download it and use it, when you really should move on from that. I can't really tell you much more about that, and if it's not really something that you need to know. But ultimately, it's nice to use the newer versions of languages. It's not nice to use the latest of something, because there's always issues, there's always bugs. Those semantic errors are easier to find after time than immediately. But you definitely don't want to use outdated stuff. So if you're just learning Python, hopefully this gives you enough reason as to why you should be using 3 instead of 2. Okay? But if like 4 came out tomorrow, I would not tell you like, hey, go use 4 now. No. Let somebody else be the test rat, basically. You wait a little bit till things are stable, and then you move on. Okay? Now, there's not that many differences to the point where, like, if you see Python 2 and Python 3, you're going to be completely lost. They're very small amount of differences, but they're still enough for things not to work. So if you do run into a situation where you do find this library that you really like, but it only works for Python 2, not to worry. You can take knowledge from this class, apply it to Python 2, and maybe we spend one day looking at the differences so you can get that going. So if as you're looking for your project, there's something you want to do and you find a library that only works for 2 because nobody else ever updated it again, that's not going to be a major issue, okay? But I just would discourage you from actively pursuing Python 2 when Python 3 is out. Anyone have any questions, comments, or concerns, I suppose? I have to update this here. To use Python. Okay. Well, I think that's more than enough talk. Let's do some coding. If you're all still awake here. All right. So, like I said, you should all have Python ready to go, so I don't really have to worry much about that. So what I would like you to do is just open up some Python IDE, Python terminal, and then just kind of code along and just try a couple of things to kind of get your, what do you call it, get your feet wet or get your hands wet. Yeah, something like that, okay? So if you're running on the terminal, it would look something like this. You put in Python 3, and then you get this interpreter running. Or if you're running it on an IDE, you just write the code in there, and then you execute the code. Okay? So either or is fine, but I would prefer you to, for now, and for class in general, to use this one, because what this is doing here is that you can write Python code, and it'll work. But the moment you exit, you didn't save anything that you did. So this interpreter here is nice if you just want to do like a quick math operation or something really quickly, like you're prototyping and whatnot. But if you're trying to write an actual script to run later or run more than once, then it's much better to write the script somewhere, save that script, and then execute it. And if you want to execute a script that you already wrote, you got to know where it's at. So in my case, I believe it's in my desktop. Yeah. And the way you run a Python script is you type the word Python 3 in front, you put a space, and then you put the name of the script, which in this case I named it python1.py. I would discourage you from naming things with the word Python in them. Just name them something that is actually relevant to what you're doing. So data analytics project, or homework assignment 1, or whatever it is you're working on. If you're working on a thing for measuring the number of people going to a football game, then call it football measurement.py. Okay? And the .py extension is telling the computer that this is a Python script. I never tried to run it without, but it's just good to have it. So don't, just add that .py. And .py files can be opened in any text editor, by the way. So if you're in Windows and you have a .py file and it doesn't open, it says like it's an unknown file type, just go in there and change the properties to open it. In fact, I might, I can show you what that would be like. This is a new computer, so maybe it actually won't recognize it. So let me see. Let me just make a test file.py. Okay. So now this is my Windows host machine. And so I have a test file.py. It's just a text file, but it's empty. So if I click it, Windows is like, yo, what is this file? I don't know what this is. Panic mode. And that's because actually it's a new computer, so I've never opened a Python file. So it's perfect. So what you do is in here, just go ahead and find a text editor. Obviously, if you have your IDE like PyCharm or whatever, select it. But if you don't, then you could open it with Notepad. You could probably open it with Microsoft Word, but I would discourage you from doing that. That's going to look weird. So Notepad's going to be your best bet. Or I encourage you to download Notepad++. It's a really nice text editor that's just like bare bones. It's not really meant for coding, although you can code there. But it's a little more flexible than Notepad, because when you're dealing with files between different file systems, between like Mac, Linux, and Windows, it might have different line feeds at the end of the line. So the things that make it go to the next line, the carriage returns. And so things might look all like in one line if you're opening a Linux file on Windows or in Mac versus Windows. And Notepad like resolves those issues. So yeah, just go ahead and select that. And then check this. It says always use this app to open the file. And then go ahead and open it. And then bam, it's empty right now, but I could write something. Okay? And then this is what Notepad++ looks like. If you're on Mac, it'll be some similar process when you're opening a file. But you could also just open it in a terminal. If you already open it with something else and you want to change it, you can go to Properties and then hit Change here on Opens With, and then select the program that you would prefer to use to open the file with. Okay? If you want to cancel that, press Escape, and then that's it. So I'm just going to delete that. Okay? That's what it's like on Windows. If you're on Linux, let me just find it. Here it is. Then you can hit on Open with Text Editor or Open with Other Application, and yet again it'll be the same thing. I don't have Notepad++ here because I have the VS Code, but you can change what file it opens with. I don't have a Mac here in front of me right now. I mean, I do have one back there, but hooking it up and getting everything ready is too complicated. But it should be some similar process to this. And if you install via Homebrew, which Claire, I hope that Claire, I hope that you got that set up. If not, talk to me after class and we can finish setting that up. But yeah, if you've got that set up through the terminal, then you can do literally what I'm typing here with the Python 3 part. Okay, and then you can edit it. If you're a terminal person, then you can use a terminal editor to modify files. So for example, if I would like to modify my text file via the terminal, there's a command called nano that will open a text editor, as you can see here. There's also other ones like Emacs, gedit, Vim, and other ones, but I won't really show them to you because I'd really rather you use an IDE anyways. This is more for like when you're in a stranger's computer and you just need to quickly open a file to make a tiny tweak or something, like if you're doing a demo or something. So that's the basics. It might be useful for me to give you a quick crash course on how to use a terminal for your operating system that you use. So I might do that maybe on the Thursday recording or something. And then I can also pull out the Mac and record from that one for that or something to make sure you're all aware of that. Okay? But for now, just set this up and then let's get going. Okay? So the first thing that is good to do when you're trying to code something is to make it see if a code runs, right? So you want to write the simplest possible program that just does something basic, just to make sure that your installation is correct, your interpreter is set up, and you can actually see output of a program. And so it's a tradition for programmers, first program on a new programming language they learn, to do a hello world program. So that's what we're going to do. And that is a program that is going to print out to the terminal the message hello world. Turns out that in Python this is very easy to do and it takes one line of code to do. This is what the line of code looks like. But let's actually look at this carefully and see, because this might be a single line of code, but there's a lot of concepts in this that we won't even cover today. But for now, you kind of have to just go along with it. So it turns out that this is what is this print and then parentheses is what's known as a function. Some people call it a procedure, some people call it a method, depending on who you ask. Those are, well, some people say they're interchangeable terms, some people have specific definitions for each. For me, it doesn't matter which one you use. I prefer function. Okay? So because of like the mathematical sort of history of that name. So although for mathematicians, a function typically returns something, and there are things as functions that don't return anything in Python, in which case maybe the word procedure or method might be better. But I'll just go with functions being able to return or not return anything, okay? So it turns out that here, print is what is known as a function. And that function is an example of what I was talking about earlier with libraries, where like you don't want to do all the nitty-gritty stuff. You want to let somebody else handle it. For me to tell a computer to print something out in the terminal requires like a lot of work. Like it might seem simple, but like behind the scenes, there's a lot of stuff going on to be able to communicate between a processor and like get everything going and then actually be able to print out. It's a lot of magic behind the scenes that you definitely don't need to know. So that's all I'll say about that. There's some magic that happens, but you don't need to know it. So all you do is you use this function called print. Now you'll see that in my IDE here, it actually, when I highlight the word print, it pops up some description. This is the documentation for the print function. It allows me to see how to use the print function and all the different features it has. You can see the word function there. That's because this is a function. And then it shows the function name, which in this case is the word print. And then it shows me all these fancy things that you don't know yet. You will at some point. That explain how to use this print function. Just know that that's there for you. Again, right now a lot of this is like, whoa, what is all this like str and like asterisk and a bunch of dots and equal signs and flush and all these fancy words and different symbols like square brackets and vertical line. Don't worry, that would all make sense within time. But what you can definitely read right now is the documentation description beneath it that says print the values to a stream or a system.std out, which stands for standard output, by default. Optional keyword arguments are file, sep, and flush. File allows you to select where you want to print to in a way. Sep is something to define how you want to separate different things that you print. So print allows you to print more than one item at a time. And when you print multiple items, like we'll do in a minute here, it automatically separates them with a single space. However, you can change that to separate them with other things if you'd like. And so on. So you basically get a description of how to use it. and then you get examples above of how it should look like. So that's kind of what the documentation is like, and it's very, very useful when you're starting to code if you don't remember how to use a function. It might be intimidating, but trust me, all this information is very helpful. Okay, so we got our print function, and then you can see that we have the parentheses. The parentheses, when you write a function, the syntax of that function is going to be the name of it. So some name can be whatever you want, and then some parentheses, open and close. These parentheses allow you to put things to the function. Think of like math. In math, when you're writing a function, you say something like f of x is equal to 2x plus 1, right? This is what like math looks like. Hopefully you all remember that, right? So, well, we have one person here who's in the math department, so he can definitely tell us, if refresh our minds if we don't remember things, right? So, yeah, we got our f of x is equal to 2x plus 1. Okay? So, this x right here, if you remember, is what you're feeding into this x here. So, if you say something like, what is f of 2? What that means is that you're supposed to take this x and replace it with a 2. And please correct me if I'm wrong in my overgeneralization, computer science view of math. But yeah, that's basically what you do. So in a way, what you're putting in these parentheses is the parameters or the arguments that you're feeding into your function. Now in this case, we have just one argument, right? And this is f of x. But in programming, you can actually pass multiple things. So if I have something like this, then my function could be something like 2x plus 5y minus 2, something like that, right? And so if I feed it something like f of 2, 4, and this is not Python code, by the way, I'm just typing here because it's convenient so you can all see it, and it's nicer than my handwriting. What this means is basically plug in the 2 there, plug in the 6 there, and then compute that, which means that this should be equal to 4 plus 30 minus 2, which is going to be equal to 32. Right? So that's your math review. So that's how functions work in Python. You pass parameters in them like that, okay? And I'll teach you how to actually use them much later. But right now, you need to be able to call a function that already exists. We will build them later. That's what I mean. You'll get to build your own functions later in the semester. For now, we're just using pre-made ones. And the first example of that is going to be your print, okay? So, with the print, this is going to be our first argument. This is our x, basically. And you'll notice that there are quotations around the hello world, okay? So let me switch back to the iPad so that I can kind of explain how that works. So we got our print. And we got our hello world. Can you see that? Hold on. You can't see it. There we go. Please, I hope that this is not something that just... Okay, there we go. I was like, I hope that hasn't been happening for the past hour. Nobody told me, but yeah. Okay. So, so we got our hello world, right? So if we think back again to the function like f of x is equal to 2x plus 5, the idea is that what we're passing in here is going to be fed here, right? So with the print function, you could see it. Okay, thank you. That's good. So yeah, if I ever get stuck, please like immediately tell me so I don't just start talking. So this is our x right here. And what the print function is doing is it's taking this value, so you can think of as x equals the world, and feeding it. Except in our case, the print function does not make 2x plus 5. What it does is it tells the computer to print to the terminal whatever is passed in, which in this case is this. So the result is that we're going to see this print out in the terminal. Okay. So if I run the code, in my case, I just press F5, then you can see down here that hello world is printed. If I do the same thing in the terminal, by putting Python 3 in front of it. Like this. And I run it, I can see hello world. And congratulations, you just wrote your first program. Okay? Let me know if you get stuck or if you have problems with it or anything like that. If you're using an IDE, you usually have a thing that says like run without debugging, start debugging. So, and that's how I am getting it to run. Okay? So let's go ahead and print something other than hello world. So maybe you want to say hello world or from Data Analytics 621. If you want to pass more than one thing in math, like I was saying before, all you got to do is say f of like 2, 5, right? If we're doing something like 2x plus 5y. Well, actually, by the way, I was saying earlier like 5y like this because we were saying f comma xy. But you could also use subscript. So you could say like x1, x2, x1, x2. Right? So either one is fine. Again, this is an oversimplification of the real math stuff that people do, but it's just so you get the idea. So let's go ahead and do something that passes 2 arguments in. So we can do that by putting a comma, just like you would in that example that I did earlier, and then passing something else. So this time, let's pass a number in. Or no, actually no, we were going to do the from data analytics. Say from data analytics 621. You save it, you run it, and now you can see that here it says hello world from data analytics 621. If you did the same thing in the terminal, you can see that it is happening there as well. These are technically two variables. Now let's go back again to what I was saying with these quotation marks. Like, what do those quotation marks mean? Well, that's another syntax rule. So whenever you're trying to print out text, or at least pass text to a function or assign it to a variable or anything of that sort, what you're doing is you're trying to tell the computer, like, okay, this is not a variable called hello. This is not a function called world. What this is just text. And so you use either double quotes or single quotes. Actually, Python allows you to use either one. And then it considers whatever you pass in there to just be text. And that text has a name, and it's called a string. Okay? So whatever is contained between the single quote or the double quote is known as a string. And basically, it allows you to print out any text that you'd like. Okay? So that is why we have to put quotes around hello and around data analytics. However, you could simplify this because I could just make this one big string by doing that. And then if you run that, you can see that we got basically the same. They both look identical. Why do they look identical? Because in the past, as I was saying when I was like talking about like the different parameters here, there's one option that basically by default, when you're passing in multiple parameters or arguments to this print function, it will separate them by a single space. And I hadn't put a space. But if I put a space like here, then when I run this, I'd actually get 2 spaces, as you can see from here. Okay? So I guess that's good to keep in mind when you're thinking about making your output look pretty. Okay, let's say that we wanted to pass the 621 as a separate argument. We could do that. We could even pass it as a number. 621. However, this won't look like pretty because I'm missing one tiny thing. Actually, no, I'm not missing anything. No, this will look normal. I was gonna say, I might need to add a space here because the 621 will be literally touching the S. But no, because of what I was saying with the separator, it'll add a space for me. Let's see it in practice if that's what it does. Yep, it added the space for me. Cool. However, this is being not understood as a text or string. It's being understood as an actual number. But the print function does the magic of not having a problem combining both text and numbers to make it look like all text. again, this is that magic behind the scenes that allows you to know how to do things like excruciatingly basic, like that. So yeah, this is how you do output to a terminal from a program. And it's very, very important because it allows you to see what is happening, right? So now when you're doing all your fancy calculations and predictions and analytics and everything, you can at least print out the results of the terminal, because what good would it be if you run a computer program that basically cures cancer if you can't see what the cure is? It's just like, yeah, I cured cancer, but that's it, right? You want to actually be able to see what that output is. So that's why it's very important to be one of the first things that we show you. And so that's pretty much what I wanted to cover for today. Again, very basic stuff, as I warned you. This is kind of like an introductory thing. So I know some of you probably were put to sleep by this, but you know, I have to make sure that we're all on the same page when we start to get to some of the fancy stuff. So the next class that I'll do, which will be the one for Thursday, that will be a recording, and you can watch it on your own leisure before the next class. I will keep going with this and go over things like variables and basically see as far as I can get. But yeah, if anybody has any questions on that, you can message me, email me, or just bring them next class as well. Okay. In addition to that, I encourage you to keep looking for your projects. Just, I know it's early on, but you know, it's never too early to start. Find something cool that inspires you, that motivates you. But other than that, thank you all for attending, and I hope that for those of you that are like flat out new to programming, that this was not like over your heads and things, which I don't think so. I think I went very basic here, but please let me know if that's not the case. Okay? So thank you all for coming. I do appreciate it, and I do wish you all to have a good day as well. Thank you, everyone. Stop all the recordings. There we go. And I'll stop this one. Great. Thanks. Bye.